Hi everybody. Today we're starting Unit B. And in this lesson, they want us to think about the relationship between numbers in an equation showing equality and decide if the statement is true or false. Look at this statement. 7 plus 8 equals 6 plus 9. Is this true or false? You might be thinking, I can easily prove this true. 7 plus 7 is 14, and then 1 more is 15. So 7 plus 8 is 15. And 6 plus 9 is also 15, since if I take 1 from the 6 and add it to the 9, I get 10, and then 10 plus 5 is 15. 15 is equal to 15, so of course it's true. But is there a way to prove that statement true without adding those numbers together? To do that, you have to look at the relationship between the numbers. In this problem, I look at the relationship between my numbers, and I can see that 6 is 1 less than 7, and 8 to 9 is 1 more. Since 6 is 1 less than 7, and 9 is 1 more than 8, those two changes cancel each other out, and I know that my equation is true. So I can prove that 7 plus 8 is equal to 6 plus 9 by stating, since 6 is 1 less than 7, and 9 is 1 more than 8, this statement is true. Now I know this is a very different way of thinking than you've done before. Usually, on these kind of problems, your teachers would tell you, add both sides, see if they're equal. And that strategy will work. But what if you had to do it without adding? Look at the relationship between the numbers. In this problem, I see 24 plus 15 is equal to 13 plus 23. I can easily compare 24 and 23. Those numbers are close together. 23 is 1 less than 24. If I compare 15 and 13, 13 is 2 less than 15. Looking at the relationship between these numbers, I see that both numbers on the right side of the equation are less than the numbers on the left side of the equation. In this case, those changes will not cancel out, and the equation is false. My statement would look like this. Since both 13 and 23 are less than the numbers of 25 and 15, this statement is false. Take a look at this example. Try to compare the numbers that are close together. 245 and 240, 25 and 30. Do you think this statement is true or false? Pause the video and write this example down. Write what you think. Is it true or is it false? Did you look at this equation and say that it was true? If so, you are correct. When you examine the relationship between the numbers, you can see that 240 is 5 less than 245, but 30 is 5 more than 25. Since 5 less and 5 more will cancel out the changes that were made, this equation is true. And again, I can say that it's true because 240 is 5 less than 245, and 30 is 5 more than 25. Let's look at one with bigger numbers. Now I have a thousands place number. Watch while I compare these numbers. You do not have to write this example down. 5,019 and 5,000 are close together. In fact, there's 19 less in those two numbers. 3,981 and 4,000 are close together. I'm hoping that that is 19 more. Looking at my tens and ones, I can see that 9 more ones would bring me up to 90, and then 110 would bring me up to the 1,000, in this case, jumping me to 4,000, and it is in fact 19 more. So I can prove this equation true with the explanation of true because 5,000 is 19 less than 5,019, and 4,000 is 19 more than 3,981. Let's look at one more example with thousands numbers. Take your time and try to solve this one on your own. Again, compare the numbers that are close in value and see if you could prove this equation true or false. Write this example down, including your explanation, in your notes. When you compared these numbers, were you able to see that 4,525 compared to 5,000, 5,000 is 475 more? If I look at 2,475 and I compare that to 2,500, 2,500 is 25 more. Because 2,500 is 25 more than 2,475, this equation is false. And my explanation can say false because both 5,000 and 2,500 are more than 4,525 and 2,475. Now that we have some idea what it looks like to compare numbers on an equal sign equation to see if they're true or false, let's see if we can use that same relational thinking to decide if we can find a missing number. Let's take a look at this problem. 10 plus 9 is equal to n plus 15. In this problem, just like in the other problems, I could add, and I could say 10 plus 9 is 19, and 19 is equal to n plus 15, and then find that I need 4 more, because 4 plus 15 would give me 19, to tell me that n is 4. In this case, that letter n simply stands for my missing number. We call that a variable. You've been dealing with missing numbers since kindergarten. Back then, they may have put a box or a circle. As you get older, we replace those shapes with variables. It doesn't matter which letter they use. The number that makes the statement true is the correct answer for that problem. Now, if I wanted to use relational thinking to solve this problem instead of addition, I would have to compare the numbers just like I did in the other side. In this case, I'm going to say that 10 to 15, 15 is 5 more than 10. That tells me that my missing number has to be 5 less than 9, and tells me that my missing number is 4 because 15 is 5 more than 10, so n must be 5 less than 9, and 9 minus 5 is 4. Let's try another one. And let's use relational thinking. X plus 27 equals 120 plus 7. If I compare my numbers on both sides of this equation, place value seems to be the easiest relationship for me to make. I see 7 ones in 27 and 7 ones in 20 plus 7. I also see 2 tens in 20 and 2 tens in 120. The amount that I'm missing is the place value of 100. That tells me that the missing number is 100. And my explanation would explain the place values I saw. X is 100 because both sides have 7 ones and 2 tens, but there are no hundreds on the left side and 100 on the right side. Take a look at this missing number problem. 419 plus 31 equals 50 plus b. It's harder for me to compare the place value on this number, so I may have to compare the increase in the numbers like I did with my first problems. See if you can compare the difference between these numbers. What if you look at the difference between 31 and 50? Can you use that to figure out what you would need for b? without adding both sides of the equation? Pause the video. Try it. Write this example down and explain your thinking. Then replay to check your work. When you compared your numbers, did you see that from 31 to 50, there is an increase of 19? $419 then needs to be decreased by 19 for B. That tells me B is equal to 400. And I know that because 50 is 19 more than 31, so B has to be 19 less than 419. 419 minus 19 equals 400. I know this is a very different type of thinking than you're used to. I want you to think about what this could look like. In class on Monday, we're going to practice with our friends in pairs and triads to see if we can solve these problems using relational thinking instead of addition. Thank you very much, and have a good night.